After you have become familiar with the basic techniques of dimensioning, you must learn how to select the dimensions which are needed on your drawing. To do this, you have to think about the machine which the drawing represents, how it works, and how its parts fit with each other. The selection of distances to be given is very important in making sure that a machine functions properly and all its parts work together. How are these dimensions decided upon? From the functional requirements, the breakdown of the part into its geometrical elements, and the requirements of the shop for production, this selection is made. All parts of machines and structures have some function to perform. Pliers to cut, the wrench to tighten the bolt, the faucet to allow water to flow or stop it from flowing, the desk drawer to slide easily. In selecting dimensions, consider the function of each part and give dimensions with proper tolerances for the parts which must fit and work with other parts, such as the open end of the wrench which must fit the bolt head. Other dimensions of the wrench are not so critical. Parts which must work together, called mating parts, have highly functional requirements. The cutting edges of these blades, the hole in the blades for the pin to fit, and the pin itself must be dimensioned with closer tolerances than other parts of the pliers. In selecting dimensions, you must also consider the manufacturing process that will be used. Here, for example, the drawing shows the diameter of the hole rather than the radius, because standard drills are graded according to diameter. To understand further how function and manufacturing process influence your choice of dimensions, consider this drill press vise and imagine you have to dimension the movable jaw. Notice how the vise works, how the jaws move, and how the fixture is held between the jaws. Since you are going to dimension the movable jaw, notice how it fits with other parts of the vise, how it fits closely against the bed and yet slides along, and how the threaded shaft turns in the hole. Think about the movable jaw and its mating parts carefully, for these parts must fit exactly, though the dimensions of the outside or air surfaces are not so critical. Consider other dimensions of the vise also, where they affect the functioning of the movable jaw. Imagine that parts of the bed can be removed so you can see the movable jaw tongue. Notice how it fits into the slot and slides back and forth. These mating parts, the tongue and the slot, must work together. Give direct, positive dimensions for them, correlated so that the parts will fit. Do not ask the machinist to subtract this dimension and this dimension from the overall dimension to get the width of the tongue, because a dimension given indirectly is less accurate than a direct positive dimension. For the same reason, it is not good practice to give this dimension, and the overall dimension to secure the width of the slot. Give the workman direct positive dimensions for the width of the slot and the width of the tongue. On the drawing of the movable jaw, place the dimension for the width of the tongue like this. For the same reason, give the thickness of the slot and the height of the tongue as direct correlated dimensions. On the drawing, indicate the height of the tongue like this. Notice that the hole in the movable jaw must be aligned with the hole in the base so that the threaded shaft will not bind. correlate the dimension from the center of the hole to the side of the tongue with the dimension from the center of the hole in the base to the side of the slot. Dimension from the center line of the hole in each case, because the shop must locate the center in order to drill the hole. Give the dimension showing the distance from the center line of the hole to the edge of the tongue like this. Likewise, the height of the hole in the movable jaw must correlate with the height of the hole in the base. Give the distance from the center line of the hole to the base bed surface to correlate with the distance from the center line of the hole to the base of the movable jaw. Show the distance from the center line of the hole to the base of the movable jaw on the front view, because their relationship shows best in this view. The diameter of the hole in the movable jaw must be correlated with the diameter of the cylinder on the end of the shaft. Give the diameter of the shaft cylinder and give the diameter of the hole in the movable jaw. On the drawing, use the diameter instead of the radius, because it is difficult to measure the radius of the hole on the movable jaw. Specify this diameter as a bore note, because boring is necessary to produce a flat bottom in the hole. Since the cylinder on the end of the screw shaft and the hole in the movable jaw are mating parts, they must be correlated in length also. If you could see inside the hole, you would discover how these parts should fit. Notice that the hole has a flat bottom produced by boring and that the cylinder pushes against it. Giving the depth of the hole is one case where a finished surface can be dimensioned from an unfinished surface because a close fit is not involved. Any interference is eliminated by making this depth considerably less than the length of the cylinder on the shaft. On the drawing, give the depth of the hole with the bore note. The taper pin, which keeps the cylinder from coming out, must fit with its mating part, the taper pin hole. The hole will be drilled and taper reamed to fit the pin, which is a standard taper. Give the dimension as a note to drill and ream. Here is a case where the choice of dimensions is governed by the shape of the mating part. The taper pin fits in a groove in the shaft. Notice again how the shaft pushes on the bottom of the hole. On the return move, it is held in place by the groove, which fits around the taper pin. This means that the distance from the end of the shaft to the side of the groove must be given. The dimension to the side of the taper pin hole would correlate with the dimension on the shaft. But in order to drill the taper pin hole, the shop must locate its center, not its side. Therefore, give the distance from the bottom of the shaft hole to the center line of the taper pin hole. Show this distance on the side view. When the shaft and the pin are in place, the pin must clear the bottom of the groove in the shaft. This means that the distance from the bottom of the groove to the center line of the shaft and the distance from the taper pin hole to the center line of the shaft hole must be correlated. Again, however, the shop must locate to the center line of the taper pin hole. Therefore, give the distance from the center line of the shaft hole to the center line of the taper pin hole on the movable jaw. The directly correlated dimension on the shaft would be impractical to measure. Therefore, use the diameter of the neck as a correlating dimension instead. Show the distance from the center line of the pin hole to the center line of the shaft hole on the side view. The base of the movable jaw is screwed to a plate below the bed of the vise. Since the screw holes must be the same distance apart on the plate and on the movable jaw, the distance between the centers of the holes in the plate and the distance between centers of the holes in the movable jaw are correlating dimensions. On the drawing of the movable jaw, show the distance between center lines of the screw holes on the partial bottom view. The plate must be aligned with the movable jaw tongue so that it does not hit the sides of the milled groove. Therefore, the screw holes must be centered in the movable jaw and in the plate. Give the distances from the center line of the screw holes to the edge of the plate and to the edge of the tongue on the movable jaw. In order to position the plate and the movable jaw tongue lengthwise, the screw holes must also be located from the ends of these pieces. Give the distance from the center of one hole to the end of the plate and the distance from the center of the corresponding hole to the end of the tongue. Show these dimensions for the movable jaw on the partial bottom view. The holes for the screws in the movable jaw must be drilled and tapped. If you could see inside, you would discover that the tap depth on the movable jaw must be greater than the entry of the screw, which is determined by the length of the screw and the thickness of the plate. The drill depth should be greater than the tap depth. Give the depth of the drilled hole and the depth of the tapped hole in a note on the drawing. The tapped hole is a case where dimensioning is governed by shop requirements. So that the jaws come together, the length of the tongue must be less than the length of the movable jaw. Otherwise, the tongue would hit the round end of the slot, which results from an end milling operation. Since this end of the tongue will be cut off by a machinist, you should provide a dimension to show the size cut he must make. Give this dimension, which establishes the length of the tongue on the side view. The height of the movable jaw must be the same as the height of the base jaw to assure alignment of parts which are held in the jaws and rest against the top surfaces. Show the height of the movable jaw on the side view. The width of the movable jaw must be established to correlate with the width of the base jaw. Give the width dimension and, to control symmetry, give the half width also. The V cut in the movable jaw is used to hold cylindrical pieces in a vertical position. The sides of the V will keep the cylinder from slipping laterally. Give the included angle and the width because they are most convenient for the workman to use in making the cut. Show these dimensions on the top view where the shape of the V appears and the dimensions are easiest to read. So far, all the dimensions you have considered are important to the functioning of parts of the drill press vise. Other dimensions have only strength requirements. Consider the pattern maker primarily in giving these dimensions. He will need the length of the movable jaw, the thickness of the jaw face, and the height of the jaw face to the unfinished surface. Specify the radius of the back of the jaw. He will also need the thickness of the base and the location of the center for the semi-cylinder. Give the dimension of the semi-cylinder as a radius This is acceptable to the pattern maker and follows the usual practice. Follow the usual rules for placing these dimensions on the drawing. Give the necessary notes for fillets and rounds, and you have finished the dimensioning of the movable jaw. Instead of these symbols, which have been used here to stress the principles involved, you will, of course, use actual dimension values on your drawing. There are no automatic rules for selecting dimensions. You will need to exercise good judgment, to understand the function of the object, and to consider the requirements of the shop, as was done in this case, where the operator must locate the pinhole center rather than its edge. Remember that dimensions for mating parts, which are highly functional, usually require close tolerances. Less critical dimensions can be given fractionally. Consider the needs of the pattern maker in dimensioning air surfaces. And finally, remember that it is not enough to be able to choose the right dimensions. You must also know the correct symbols to use and how to place them on the drawing.